guys, today we will be discussing about the circulatory system and how the circulatory system functions. This presentation is by Sai Vandanapu. A little about me. I go to Elizabeth Lane Elementary School and I am studying 5th grade. I am 10 years old. People love to call me as Sai. Before I go any further, I want to spare some time talking about these 11 important systems that are located in the human body. Out of these 11 systems, we've already discussed about the digestive system, the respiratory system, and the skeletal system. We've also discussed these in videos. In case if you want to know more about each of these systems, added the links in the description below as part of my description. And today I want to talk about more about the circulatory system. These are all the key points as part of my presentation. The points I want to highlight and emphasize more are the scientists who first educated about the heart, the parts of the heart, the valves, and the 4 major types of arteries. First, let's talk about what is exactly the circulatory system. The circulatory system pumps blood through the body. Have you ever wondered how blood is flowing through the body and it is being pumped? That is because of the circulatory system. The heart has a job in the circulatory system, and in this presentation we are going to discuss about the job and what is the job and how the heart does its job correctly. The heart works harder than any other muscle in the body. After watching this video and this presentation, you will agree with me that the heart works harder than any other muscle in the body. The heart never rests or stops working. Imagine the heart stops working, which means the human body is dead. Now, if the heart beats slowly and at a low pressure, which means low blood pressure, and if the heart beats faster and higher, which means high blood pressure. The heart pumping. Before I talk about this, I want to say that the circulatory system has another name, which is called the cardiovascular system, which consists of the heart, the blood cells and the blood vessels, and last but not least, the lungs and the arteries. Now let's go back to the heart pumping. The heart pumps blood to human body through the circulatory system, right? And if the heart stops pumping the blood, which means the body is dead. Now in this picture I have shown you the diagram and how the circulatory system is structured. This is the circulatory system structure and this is in its body. Now when the heart is pumping, think about this. When you're blowing and expanding a balloon, it then compresses, right? Expands, compresses, expands, compresses. In the same way, the heart is functioning like a balloon. It expands, compresses, expands, compresses. It's like when you're squeezing a sponge, you squeeze it, it compresses real hard. But when you let it go, it expands again, which is exactly how the heart is also functioned. These are the 2 examples of the heart that it is similar to. The types of the muscles I'm going to be talking about, these are the 3 types of muscles I'm going to be talking about. The skeletal muscles, the cardiac muscles, the smooth muscles. Now, you see this photo here. I have placed the photo of each of the muscles that I'm going to be talking about. This is the cardiac muscle, this is the skeletal muscle, this is the smooth muscle. The skeletal muscles are muscles that are connected to the bones. These muscles here are called skeletal muscles. You're probably wondering why these are very straight. This is because they are connected to bones, which makes them the name the skeletal muscle. The cardiac muscles are muscles that are only found in your heart and can move without a command, similar to the smooth muscles. These cardiac muscles are located in the heart. Now let's talk about the smooth muscles, which is the last kind of muscle. Smooth muscles are muscles that move without a command, and there are smooth muscles in the esophagus and the small intestine. You're probably wondering what is the esophagus and small intestine. The esophagus and small intestine are play a major role in the digestive system. Now, if you have not seen my digestive system video, don't worry, I have provided that also as part of my description. Before I move any further, I want to spare some time talking about the scientists who first educated about the hearts and educated us. They have spent their lifetime educating us with the heart. The four we are going to be talking about are Dr. William Harvey, Dr. Ludwig Rain, Dr. Christian Barnard, Dr. Robert Jarvik. I have placed the photos for each and every scientist I'm going to be talking about. These four are the part of many scientists who have spent their lifetime educating us about the heart. First, we'll talk about Dr. William Harvey. Dr. William Harvey was the first scientist to discover how the blood circulated through the body. This discovery took place in 1628, which is more than 400 years ago, which is why I have placed a painting. Now, if I place a real photo of him, I couldn't even find one because he was very, very old and back in time. Next, we will be talking about Dr. Ludwig Rain. Dr. Ludwig Rain was the first doctor to complete an operation that consists of stitching up a wound in the heart of a German soldier. This operation was taken place in 1896. As you can see here, this man is also from back in time. You know how I found that out? Because back in those days, the cameras were black and white, and he was taken by the camera at that back in time. So he was an old fellow. Dr. Christian Barnard was the first doctor to complete a transplant operation. You're probably wondering what is a transplant operation. A transplant operation is when you're taking the heart from a human or another person and placing it into a human that is dying of heart damage, which is exactly what Dr. Christian Barnard did. He took the heart of a 25-year-old woman who had died in a car accident and placed it in the body of a 55-year-old man who is dying of heart damage. This operation took place in 1964, which is a very old time indeed. And he too was taken by a camera back in time. And those were also black and white. Last but not least, we have Dr. Robert Jarvik. He created the first artificial heart that was going to be placed in the body of a 61-year-old dentist. You know what he called this artificial heart? He named it after his last name and a 7, so it was called Jarvik 7. And this took place in 1982. But he is also a very recent man, as you can see here. Now that we learned all the scientists who have spent their lifetime educating us about the heart, now let's use that knowledge, and I'm going to discuss the parts of the heart, the very common parts of the heart, because there are many parts of the heart. First, we have the right ventricle. The right ventricle is the chamber within the heart that is responsible for pumping oxygen-depleted blood to the lungs. The The right ventricle is located right here. Then we have the left ventricle. The left ventricle functions to pump oxygenated blood from the lungs to the body. So the left ventricle is right next, but there's a muscle dividing it that we will be talking in this slide. The left ventricle is right here. Now we will be talking about the muscle that divides the left side and the right side of the heart. This muscle is called the septum. The septum's job is to divide the left side and the right side of the heart. You know why this is the job of the septum? Because it prevents the mixing of the oxygenated and the unoxygenated blood. Next, we have a right atrium. The right atrium is the first chamber of the heart to receive deoxygenated carbon dioxide rich systemic blood from the body, which is a kind of blood. The right atrium is located on top of the right ventricle. The left atrium. Now, the left atrium is the first chamber to receive the oxygenated blood from returning from the lungs. So the left atrium is above the left ventricle. So now that we know how the heart pumps and what are the 5 common parts of the heart, let's learn about the valves that are in the heart. First, I'm going to list out 4 common valves: the tricuspid valve, the pulmonary valve, the aortic valve, the mitral valve. Now let's walk through each and every valve. The tricuspid valve helps keep blood flowing in the right direction through the heart, which is right here. Next, we have our pulmonary valve. The pulmonary valve opens at the systolic phase of the cardiac cycle, enabling the deoxygenated blood to be pumped from the right ventricle to the pulmonary circulation. The pulmonary valve is located in a diagonal line to the tricuspid valve, which is located right here. The aortic valve. Now, the aortic valve is a sophisticated structure that performs a range of functions resulting in the unidirectional flow of blood out of the left ventricle, the optimizing of coronary blood flow. The aortic valve is also located in a diagonal line to the pulmonary valve. Last but not least, we have the mitral valve. Your mitral valve regulates the flow of blood from your lungs into the left ventricle, the main pumping chamber, which is right here. Now that we know each and every valve, I don't mean like each and every valve, just the 4 common valves. Now let's learn about what are common out of all these valves. Common valves are, all these valves have one job, which is to let blood enter the heart and stop them from going back out of the heart. How do they do their job correctly? Now let me tell the process of it. First, when blood is awaiting, the valves open for the blood to enter the heart, which is basically the entrance for blood to enter the heart. Next, and then they close so that the blood doesn't travel back. This entire process is called heart pumping, which the heart pumps like a balloon. When you're pumping in a balloon, it expands, and when you take the knot off or like the pumping off, it compresses real hard. That is exactly how the heart is structured. Now that we learned not all about the heart, but the common things about the heart, let's learn about the arteries. Now I'm going to just list out each and every, not each and every, but the 4 common ones. There is the pulmonary artery, the aorta, the pulmonary veins, the vena cava. Now, The pulmonary artery is located right here, and the pulmonary vein is located right here, and the aorta is right here, and the vena cava is right here. Now, let's walk through each and every artery. But before we are talking about the artery, let's learn what is exactly an artery and what is the definition about it. The artery means it's a series of nerves. As you can see, there are lots of series of nerves. Now, let's talk about the arteries. First, the pulmonary artery. The pulmonary artery carries blood out of the heart and into the lungs. I've told you in the first video that the lungs play a role in the respiratory system. But like all organs, lungs play two roles, which is in the respiratory system and the circulatory system. Let's talk about the aorta. The aorta carries blood to all the other parts of the body except the heart, because that is the role of the pulmonary artery. So now you can understand that the aorta doesn't have the same job as the pulmonary artery. Next, we have the pulmonary veins. Pulmonary veins carry blood from your lungs to your heart. So it's the other way around than the pulmonary artery. The pulmonary vein is located right here. Next, we have the vena cava. The vena cava brings the blood from all the other parts of the body back to the heart. So the vena cava is right here. Next, before I move on, I want to spare some time on talking about what is the job of the blood. Now, the blood cells carry the nutrients of the food you eat. In the following slides, we'll discuss what are the blood cells that do that job. Next, there are also cells in your body that take oxygen into the lungs. There are cells that do the job. We have the blood cells that also take the waste and trash and jettisons it out of the body. When I mean it jettisons, I mean it eliminates. The blood cells are also known as the river of life flowing in your body right now, because there are many causes blood is flowing in our body right now. And last but not least, I want to say there are trillions of blood cells flowing in your body right now. In this picture, I have provided how many blood cells there are in just one photo. You cannot count how many there are in this picture. Now, let's talk about the 4 common types of blood cells. Let me just list out the blood cells. There is the red blood cells, the white blood cells, the platelets and plasma. Now, the red blood cells are in a red color. Let's say that the red blood cells carry oxygen. So when the pulmonary artery takes blood cells to the lungs can use the blood cells as oxygen to breathe the air that I am using right now. Now let's talk about the white blood cells. The white blood cells are these big white chunks. These cells stop infection from getting close to the blood cells, but too much is not good for your body. We'll talk about the platelets. Now, platelets do a big job, which is to stop bleeding. Say that the pin has just injected through your finger. That is when platelets do their job. They stop the bleeding. Once it's clotted, platelets take all the blood that has just come out. Plasma is a yellowish liquid that contains nutrients and travels throughout the body. So plasma is a very yellowish liquid that is almost invisible in here. Once you eat like a burger, once you eat it, the plasma take action. They take the nutrients out of it, which is not many, and they travel throughout the body. That's when we use the energy. Now, let's talk about some good habits to follow to keep your circulatory system up and running. Get enough sleep. When I mean get enough sleep, don't sleep in the morning like too much. Get enough sleep, like sleep early bed and early get up. When you do that habit, you will get so much blood cells that you will keep on getting energy. And you can do activities much faster. Don't drink alcohol. Don't drink alcohol because it will damage your organs and your bones. And don't smoke because it will damage your organs very badly. And you know what? When you smoke, the walls of your valves will get layered with carbon dioxide, which will make it harder for you to get energy. Which also results that when your blood is being pumped, you will only get a small tiny amount, which is not much, then you won't get more energy, which results in heart pain and paralysis. And do more exercises. When you do more exercises, you will get more energy and your heart will produce more and more blood cells, which makes more and more energy. And mix a less salt with food, because which will not be good and it will result in a very high blood pressure, which is very hazardous to your health. And fill up on more fruit and vegetables. When you fill up with more fruits and vegetables, you will get a lot of energy, which means more and more blood cells, which results in you activities very, very fast. Last but not least, we're going to talk about some fun facts. If you stretch out your whole artery system, it would be up to 95 kilometers, which would round up the earth more than twice. And when I mean I mean only one person's. The heart beats 2.5 billion times in a 75-year-old's lifetime. If you kept on counting a 75-year-old's lifetime, you would get up to 2.5 billion times. That's exactly what this fun fact says. If the red blood cells were stacked up in the sky, they would reach up to 31,000 miles. And I mean 1%. Blood is a liquid tissue, which means it's a fluid that makes up more than half. Plasma, white and red blood cells make up the remainder of this. Each second we lose about 3 million red blood cells, only to be replaced by the same number produced in the bone marrow. The bone marrow is in the bone. So these are all the 5 fun facts that we have also discussed about. And after watching this presentation, I hope you agree with me that the heart works harder than any other muscle. And thank you for your time for watching this video. And please like and subscribe this channel. And if you have any questions, comment them below. And to give you a heads up, my next video is to emphasize more and more about the blood and its blood cells and the importance of blood and what are exactly the jobs of them.